In this video, we're going to take a look at a few more examples of function composition. So we have this function, square root of x minus 3, and then x squared minus 4x minus 1. And although it doesn't ask us for the domain, we look at this and we know that the domain is going to be anything that's 3 or greater. Okay, so just going back to the beginning of this section, we know that anything under a square root has to be bigger than 0 or equal to. All right, so when we get our answer is still going to retain this, even if there's no square root expression. And so this says f evaluated at g. So what I'm going to do is I'm just going to stick g inside of f, and I'm just going to take and stick that inside. And so we get now the square root of x squared minus 4x minus 1 minus 3. All right, so what I did was I just substituted and plugged x back in, or x squared minus 4x minus 1 in for x. Simplifying, we get the square root of x squared minus 4x minus 4. And there's nothing else that we can do with this. Okay, so we're just going to leave it like that. And if we wanted to find the domain, we might have to do something a little bit more difficult than just looking at this expression. In fact, we're going to look at that in our next chapter when we deal with quadratic inequalities. So since we haven't learned that, we're not going to worry about the domain. Next, we're going to look at g at f at 4. Now, g at f says that we're going to start with g, and we're just going to plug f back in. And then we're going to evaluate that at 4. So I'm just going to take and substitute the square root back in for both of those. And so that's going to be equal to the square root of x minus 3 squared minus 4 roots of x minus 3 minus 1. Okay, so again, what we did was we just substituted x back in for each of these expressions, or x minus 3 back in for each of the x's if it's g. All right. If we simplify it, we know when we square a square root, those are inverse operations. And so this is going to be x minus 3 minus 4 roots of x minus 3 minus 1. We can combine. And so we end up with x minus 4 roots of x minus 3. And now what we can do, so this is going to be equal to g at f at x. But if I want g at f at 4, what I'm going to do is just substitute 4 back in for x into this expression. So I get 4 minus 4 roots of 4 minus 3. Those 4's are opposites. I get negative 4 roots of 1, which is just going to be negative 4. All right, so that was pretty easy to evaluate. Now finally, f at x. All right, that means that I'm going to start with f, and I'm going to substitute f back into itself. So I'm just going to take the square root of x minus 3 and substitute it back in. And so this actually just becomes a fairly cumbersome expression of the square root of x minus 3 minus 3. There's really nothing that we can do to simplify this expression. Okay, so we're just saddled with this expression, and that's it. Just a couple more examples. So in this one, we have 1 over root x plus 1, and then 1 over x minus 1. And we're asked to evaluate f evaluated at g at negative 5. And so what that means is we're going to take g and substitute it back into the x and then simplify. So f at g at x is going to be 1 over x minus 1 plus 1. Right? So again, I just substituted 1 over x minus 1 back in. The 1's cancel out. This just becomes 1 over x, or that just becomes x. All right? And so f at g at negative 5 is actually really easy, because that's just going to be negative 5. And that's it. Okay? So not too bad with that one. Now we're going to evaluate g at f at x. So we start with g, and we substitute f back in for g. So we just plug that in here. And that's just going to become 1 over x plus 1 minus 1. Oops. Let me erase that, make it look a little bit better. So this should be an x plus 1. Remember, when we divide a fraction by a fraction, we multiply by its reciprocal. So this is going to be 1 times x plus 1 over 1 minus 1. Okay, so we just multiply by the reciprocal. That just becomes x plus 1 minus 1, which is equal to x, because those 1's are going to cancel out. Okay, so again, what we're doing here is we're just taking this one and we're multiplying by the reciprocal of the denominator. Okay. Last one that we have is f at x. All right, so we're going to take this 1 over x plus 1 and we're going to substitute 1 over x plus 1 back in. This is going to be 1 over x plus 1 plus 1. Now this one's a little bit tougher to deal with to simplify it because what we need to do is we need to get a common denominator of x plus 1. All right, so this is going to be 1 over x plus 1. And whenever we have a 1, we could just write that as x plus 1 over x plus 1. Okay, so, and we can clearly see that the common denominator in that smaller denominator or in the denominator of the original is going to be x plus 1. This is going to turn into 1 over x plus 2. So we have a 1 and a 1, and then the x just becomes the x right here. And we're going to have x plus 1. And then finally, we just multiply by the reciprocal. So 1 over x plus 1 over x plus 2, or x plus 1 over x plus 2. All right. So again, the algebra is starting to get a little bit more rigorous than some of the previous sections. And so if you're having trouble with some of the algebra stuff, suggest rewind the videos. All right, make sure that you're okay with these techniques because these are techniques that we're going to be using throughout the remainder of the semester. Right. So the last video, what we're going to do is we're just going to go backwards and we're going to find functions that are comprised of one another to be able to make a composite function.